This video is to show the solution steps for the 7.8 practice that was assigned. So I'm going to go through each problem and talk you through how I come up with a strategy to solve these, and then I will actually solve them. So for number one, what we see is, and this is one of the first things you want to notice, is you want to look for, and I'm going to write this really big over here, you want to look for a GCF always first. That's what you want to do no matter what. Sometimes there won't be one, but you want to always start with a GCF first. I'm going to do that for every problem. Sometimes I'll have one, sometimes I won't. So for the first one, what I notice is both terms are divisible by 4, and both terms have a y, and the lowest power of y is y to the first. So that's what I'm going to factor out. So once I do that, I'll have a 4y in front, and then on the inside, I'll have y squared minus 9. So that's my first step, always, for every one of these. Now what I'm going to do is look at what's in parentheses and see if it means any kind of style that we've done. Does it look like any of the previous factoring we've done? Well, I notice a binomial, and I notice subtraction. So the next word that comes into my head is perfect squares, even though I know they're 2 words. And remember, we can factor perfect squares with a subtraction into 2 separate binomials, which I have here. So I have a y squared in the first term, and I have 3 squared in the second term. So this is going to factor into my 4y in front. Then I'm going to make 2 parentheses. I'm going to have a y, and then a plus 3 and a minus 3. And then I am completely factored. Number 2 is a trinomial. So let me first look for a GCF. I do not have one. 3, 7 are prime numbers, so I'm not going to have one. And it's a quadratic. It's a quadratic trinomial. So there are 2 ways I can factor this. I can factor it with the x, or I can factor using grouping. Now I'll use the x if the number in front of the squared term is a 1. But in this case, the number in front of the squared term is a 3. So I can't just do 2 numbers that multiply together give you 7, and when added give you -8. Because there actually is 2 numbers, -7 and -1. It's kind of like a trick question. But because the 3 is there, that won't work. So what I'm going to do is I'm going to group. So I am going to go over here, and I'm going to draw an X, but I'm going to multiply these 2 together. So 2 numbers that multiply together give me 21, and when added give me -8. And when I try to do that one, what I get is, so we have 7 and 3, and that's it. So this is actually prime. So this polynomial does not factor, which does happen. Okay, next one. Again, I'm going to start with my GCF, which I do have, and I see that 3, 12, and 12 are all divisible by 3, and they all have a t, so I'm going to factor out the lowest power of t, which is t to the first, with the third term. And when I do that, I have the 3t in front, and then I have a t squared plus 4t plus 4. So now I see that I have a trinomial, and again it's a quadratic, and the nice thing is the number in front of the t squared is a 1. So I can use my x factoring. So 2 numbers that multiply together give me 4, and when added give me 4. So that's 2 and 2. So I'll have my 3t, I have t plus 2 twice, and I will simplify this to 3t times t plus 2 squared. So that's our answer to number 3. Number 4, again, start with the GCF. And the GCF in this case is going to be 2q. I'm actually going to factor out the negative. I don't really like when my leading coefficient is negative. So I'm going to factor out a negative 2q. So then I'll have my negative 2q. Then I'll be left with 3q squared minus 14q minus 5. Now again, I have a trinomial. It's also quadratic, but I have a number in front. So I'm going to attempt to factor it like I did number 2 above. Number 2 turned out to be prime, but this one is not. So I'm going to multiply 3 and negative 5. I get negative 15. And then I'm looking for two numbers that multiply to give me negative 15, and when added give me negative 14. So that's pretty simple. Since 14 is only 1 away from 15, it must be negative 15 and 1. So I'm going to keep my negative 2q here. And then what I'm going to do is I'm going to group. So I'm going to have 3q squared minus 15 plus 1q minus 5. And there's my groups. I'm going to factor out. I'm going to do this over here. Thought I left you guys enough room. Going to factor out. So I still have my negative 2q. And now in front of the first one, I'm going to factor out a 3. Oops, I forgot my q here. 3q. So I'm left with q minus 5. And the second one, the only thing I can factor out is a 1, because I already have in the second parenthesis q minus 5. So now I'm done. So I have my negative 2q, and now I have my common binomial q minus 5, and then my other binomial is 3q plus 1. I always look to see if any of those can be factored again, but in this case it can't be. They're all linear factors. Okay, number 5. Again, look for a GCF first, and in this case it's going to be 5y cubed. They're all divisible by 5, and the lowest power of y is 3. Now remember, you can't factor out a variable if all the terms don't have one, but so far all the terms have had a variable that we factored out of GCF. I don't know why I made that a Q from the last problem, I guess. Okay, so in front I have the 5y to the third, and then I'm left with y squared, because I subtract the exponents, minus y minus 2. Now I have a trinomial in parentheses that's quadratic, so I can go ahead and x factor this because there is a 1 in front of the y squared. So I'm looking for two numbers that multiply together give me negative 2, when added give me negative 1. So that's negative 2 and positive 1. So now my polynomial looks like this. So I have y minus 2 and y plus 1, and everything is in simplest form. So there's my answer. Number 6, again factoring out a 7. No x this time because this 7 does not have an x, so I can't factor a variable out. So I have 7 times x squared plus 3x plus 1. Now I'm looking for two numbers that multiply together to give me 1, and when added give me 3. There are no such numbers, so this is as much as I can factor that one, just a GCF. Now for 7 and 8, we're doing pretty much the same thing, except we are solving. So we're going to factor and then set the factors equal to 0. So I'm going to run through the factoring part a little quicker, since I did some of these already, the same type. So 3j in front, and then I have j squared plus 7j plus 10. So 3j, this you can x factor into j plus 2 times j plus 5. Two numbers that multiply together give you 10. Whoops. Give you 10. And when added, give you 7. So that's 2 and 5. 2 times 5 is 10. And 2 plus 5 is 7. Now setting my factors equal to 0. So the first one, I can just ignore the 3 because 3 is a number. It's never 0. So I'll just have j equals 0. The second one, j plus 2 equals 0. So this is j equals -2 because I'll subtract the 2. And j plus 5 equals 0. Subtracting the 5, I get j equals -5. So there's the 3 solutions. Next one, I'm going to start always with a GCF. So I have a w squared I can factor out. So I have a w squared, and then I have w squared minus 36. Now this is a binomial, so I have subtraction. I'm going to look for perfect squares, w squared and 6 squared. So I can factor it again. So I have w squared times w plus 6 times w minus 6. So my 3 solutions are going to be w squared equals 0, which is just w equals 0. Here we have w plus 6 equals 0, so subtracting the 6, w equals -6, and then we have w minus 6 equals 0. Adding the 6, we get w equals 6. So here's my 3 solutions. Next one, I have 4 terms, so I know right away I'm going to be grouping. I look for a GCF first. The 18 does not have a y, so I can't factor out a GCF. So I'm going to have y cubed minus 2y squared is my first group, and my second group is going to be -9y plus 18. Factoring out a GCF from each group, the first group has a y squared, and the second group I'm going to factor out a -9. Now if you're not sure about what to do with the second group, remember you can always do the first group and see you have y minus 2. The y is positive, the 2 is negative, so that's why I wanted to factor out a -9, because then I'll have y minus 2. Okay, so now I have y minus 2, and then I have y squared minus 9. Now here you have to be careful, because that can be factored again. It's a difference of squares. That's the way it is with this section. You have to keep looking at factoring till you absolutely are sure you can't factor anymore. So this is going to equal 0, so I have y minus 2, and then the second part in blue factors into y minus 3 times y plus 3, because we have 2 perfect squares. So our 3 factors are y minus 2 equals 0. Adding 2, we get y equals 2. Y minus 3 equals 0. Adding 3, and we get y plus 3 equals 0. Subtracting 3, we get -3. So there are our 3 solutions, 2, 3, and -3. Okay, last one. I'm going to divide everything by my GCF, which is 5t to the third. I know 210 is divisible by 5 because it ends in a 0. So when I do that, I have my 5t to the third in front, and then I have t squared plus t minus 42. So that's just an x factor two numbers that multiply together give you negative 42, and when added give you positive 1. That's going to be 7 and negative 6. So I have my 5t to the third times t plus 7, t minus 6. 3 zeros. So the first one is going to be t equals 0. And again, I can ignore the 5 because 5 is a number. It's never 0. The next one is t plus 7 equals 0. Subtract the 7, get t equals negative 7. T minus 6 equals 0. Add the 6, you get t equals 6. So there are my 3 solutions. Now, the last 2 problems were graphs. Now what I've done is I went ahead, and you can look at these, and I factored these and solved them, but you didn't have to do that. This is a nice thing about graphs. Finding the solutions is the same as finding where it crosses the x-axis, because just real quick here, you have y equals x cubed minus 49x. Anytime it crosses the x-axis, you're looking for a point x comma 0. So that means that y is 0. So that's what you do. You set it equal to 0. But what I'm really looking for are these 3 points. Now in this one, it's a little difficult to see the points because they scaled it by counting by 2s. But you can kind of see that it's in between negative 8 and negative 6, and the 0 is obvious. And between 6 and 7. But you can double check it by factoring it. Number 12 is a little easier because you definitely can see the 0 that is at 2. This is the only one, and you could have estimated it was 5, but you could have solved and found the 5 as well. So hopefully this video helps some of you that were struggling to solve these problems.